I realized based on a message from Tuba Khan on my channel that I had screwed up this podcast on calcite compensation depth. This was the first course I did, in fact, during COVID, because I was stuck and was getting bored. But anyway, I enjoy doing these, but sometimes you make mistakes, sometimes you make very silly mistakes. So calcite compensation depth is the depth at which the rain rate of calcium carbonate from the top, could be in the form of calcite or aragonite, is dissolving at the same rate that it is coming down. So there is aragonite, which is more unstable, so you have aragonite compensation depth, which is a few kilometers shallower than the calcite compensation depth, because calcite dissolves at a deeper depth where temperatures are lower, pressure is higher, saturation levels are lower, and or it's not saturated, so the dissolution rate goes up. So there is the lysocline where the saturation ends, and then the dissolution of they are also called solvation and hydration, so I won't go into the details, but below the lysocline, the dissolution of calcium carbonate in general, or aragonite and calcite, begin to increase, and the depth at which the rain rate and the dissolution rate are the same for calcite is called the calcite compensation depth. And for the deposition of calcium carbonate to happen, actually the bottom has to be above this depth, because below the calcium compensation depth there will be complete dissolution of the it's all dissolved by the time you reach CCD. So I said it completely wrong. Thank you, Tuba, for pointing it out. So I'm going to add this clip at the end. It's been watched already a few times, so hopefully the people that follow will not learn the wrong thing from me. Sometimes when you do these things you are not being careful enough, so apologies, but remember that calcite compensation depth is where dissolution is complete in terms of any amount that is coming down from the top. So if deposition has to happen, then the CCD, calcite deposition depth, has to be deeper than the bottom topography. So that's what happens at these mid-ocean ridges and so on, where it's very shallow, so it's above the CCD or calcite compensation depth, but once it's deposited it can slide down the bottom and stay below the CCD or stay at the bottom and keep undissolved, let's say, and you can find deposits of calcite at deeper depths, basically because they got deposited above the CCD and slid down the bottom slopes and so on and so forth. Subtle point, important point, very important point, so sorry for screwing that up. Okay, hopefully this addition will help.